Okay, so we are going to take this graph of y equals x, x equals 1, and y equals 0, and revolve it around the y-axis. And then we're going to solve it by using shell method. Okay, so what we're going to do is revolve around the y-axis, and this graph is, this line is y equals x, this is x equals 1, and the y-axis is y equals 0. Or x-axis is y equals 0. And we're going to revolve it around the y-axis, pushing area here, so that you have a solid figure. And then what we're going to do is use shell method, and we're going to take a slice from here of infinitely small width, which is dx, and then not revolve the entire object or the entire graph. We're just going to take that bar, right, and we're going to rotate that around the y-axis. That's going to make a shell. It's like a soda can. So then, like, you have a thickness that's dx. You can take one bar of this and then rotate it around the y-axis, and that's going to give you a shell. And then what you can do is you're going to take the shell and cut it open, and that's going to give you a sheet of paper. Just like if you had a sheet of paper like this. So you took a bar and you rotate it around the y-axis, right? Same thing, you took something that's this thick and you rotate it around the y-axis, right? So through the middle is the y-axis, and you rotate it around, making a shell. So this is what you're going to get out from one piece. And then you're going to cut it open and make it a sheet of paper. And then to find the volume of the sheet of paper, it's just as volume. And the thickness of this piece of paper is dx, with the height and a width here, which is also equal to the circumference of the shell, which is 2 pi r. So then our formula for the change in volume would be the change in area times the thickness, which is dx. And then the formula that we're going to use for dx is the area for this piece of paper that we've made. And that's height times width times dx. So it's height times width, which is 2 pi r, and dx. Okay, so then now take this. And then we have the formula for the volume is the interval would be from height times 2 pi r times dx. And then our height, so we have to find the height for each sheet of paper that we're going to cut, and that's going to be the top graph minus the bottom graph, which is just going to be y equals x. So then for each height, it's just going to be x. For every x that we plug in from 0 to 1, the height is going to be that x value. And then our radius is going to be from the y-axis to wherever each shell that we made. So from here to here. And that is going to be the x value as well. So then with the height function being x and the radius function being x, we replace in our formula and we get the integral from 0 to 1 times h, which is x, times 2 pi r, which is x again, times dx. And that gives you the volume is equal to